Hi everybody, today we're going to be talking about the difference between fusion and fission. So first, fission and fusion are similar because they're both a form of nuclear reactions and they both produce energy. However, their applications are not the same and they are actually opposites of each other. So fission, in short, in nuclear physics and nuclear chemistry, is a nuclear reaction or radioactive decay process in which the nucleus of an atom splits into smaller nuclei. And when undergoing fission, for example, uranium-235 could produce two medium-sized nuclei with 2 to 3 neutrons. Those neutrons can cause even more fission, and this creates what we call a chain reaction. The critical mass is the mass needed to support the chain reaction, and the supercritical mass is the mass needed to support more fission. This is an example here of fission. As you can see, one nuclei is being split into two separate nuclei, and this is very important. It's an equation that would balance a fission reaction. Notice that uranium is in this equation. Next, we have fusion. Nuclear fusion is the process by which energy is produced by smashing lighter atoms together. It's putting things together. And then we also have thermonuclear fusion, which is fusion that takes place at extremely high temperatures, and the energy is produced in very high levels, and it cannot actually be controlled. An example is shown here, where you can see a few different regions, and they're all coming together in one. That would be them fusing together. And I put together a little compare-contrast for fusion and fission. Fission breaks things apart, whereas fusion puts things together. Fission occurs with uranium and fusion occurs with hydrogen. Fission is a reaction we can control, so that would be what we use in nuclear power plants and in reactions on Earth. And fusion is a reaction we cannot control because it occurs in the sun and stars with extremely high temperatures and of course produces way more energy.